According to the Brookings Institution, 20% of all jobs are in science, technology, engineering, or mathematics, which totals up to over 26 million positions. In fact, STEM occupations are projected to grow faster than average for all occupations, and the wages are generally higher than the national median. So the question is, why aren't there more kids studying STEM? Well, that's what we're here to figure out. In this Engineering Live, we'll discuss how to get kids more interested in STEM and why that's so important. Our expert panel will talk about their own journey into the world of engineering, how we can introduce kids to the world of science, and the challenges posed by the current education system. We'll also discuss must-have and must-skip toys for inspiring the next generation. Hi, I'm ECN editor Casey Panetta, and with me today are Nick Sogu, CEO and president of Silvertech, an agency in Manchester, New Hampshire. He's also heavily involved in educational programs like STEAM Ahead New Hampshire and Stay Work Play. Stacy Del Vecchio, ECN Editorial Advisory Board member, former president of the Society of Women Engineers, and additive manufacturing product manager for Caterpillar. Tom Ekonomu, Chief Operations Officer for Electromagnetic Technologies Industries, Inc., and Kaylee Farnham, Product Marketing Engineer at Keysight Technologies and former high school math teacher. If you have any questions for the panel during the Engineering Live, tweet at ECN Online, #EngineeringLive. So what we're going to do is kick it off with the main question. So Stacy, how do you get more kids into STEM?
So I think that is the million-dollar question. And it's really about making sure that we talk to kids about what they can do with something, especially like an engineering degree. So a lot of times with STEM things, we talk about how hard the classes are. And we need to get beyond that and start talking about all the neat things that people can do to help change the world.
Okay. And Kaylee, what would your answer to the question be?
Exactly what Stacy said, building on it, it's actually giving them examples of, for example, I work in the cell phone industry and saying, okay, how many of you have a cell phone? A lot of them. But how many of them have actually taken it apart? Not very many. And so it's giving those students the opportunities to actually see what engineering is hands-on.
Okay. I totally agree with both of you. What about you, Nick?
Sure. I think, I think it depends on what age category we're talking about. I mean, for me in particular, I have to be honest with you, I think that we've got to look at getting kids involved in STEM in kind of the K through, third grade level. That's the level where I think most interest starts. I think it cultivates through, elementary school and then really starts to accelerate in junior high. And by the time you're in high school, you kind of know if you are interested in STEM field or not. And if so, that's the path we're going to take. So I really look at it and I'm very interested in what we can be doing more in that K through third, fourth grade level, because that's really, I think, where things are starting.
I mean, I think that's a really interesting point, just because a lot of the times the emphasis you hear is on, when you get into high school or college. So, I mean, I think that's a really interesting point. And Tom, what would you say is the solution to the million-dollar question?
Well, I have to agree with Nick's point, is that the sooner the better. The other thing I think is that even if you started a little older, where they seem to understand and they can grasp concepts, I really think that you have to introduce it in a way where they're interacting with what they're learning. I think to keep their attention, they have to understand that the things that they enjoy most in passing their time and how it relates to what their studies could be. Because I think that if you sit down and teach them something without them interacting with it, it won't they won't, as many students will not grasp what they're doing versus when they're playing with it and they see how to interact.
Okay. So one of the cool things about this panel in particular is that they were all panelists were chosen because they have a particular passion for STEM education. So I'd really like to talk to you guys about why this is so important to you personally, and also your own journey into discovering engineering, and why you found it so interesting. So Kaylee, why don't you kick us off with that?
Yeah, sure. I now work as an engineer, but prior to this, I was a high school math teacher. And so I was in the classroom seeing firsthand these kids who were struggling with math and thinking that they would never, ever be engineers. And so I got to really experience it. And my actual first degree was in mathematics. And I didn't even know, as I grew up, I was good at math and science, but I didn't even consider engineering. And so I think it's so cool that I have been able to study math and then build on that. I was a math teacher, and now I'm working as an engineer.
That's pretty cool. What about you, Nick?
You know, my interest in engineering in general started at an early age. I was very fortunate that I had two parents that were professors and had access to physics labs and electrical engineering labs on campuses and things. And so early on in the third or fourth grade, I had access to essentially a robot that came in a kit form, and I found it fascinating that I could not only build this thing, and this was back before the whole Lego robotics movement started and everything started. And so for me, it was really completely hands-on, where I got to build and assemble this robot out of a kit that came out of a company called Heathkit back then. And essentially what I was able to do is build it, learn it, and play with it all summer long, and that really got me started. And then, back when I was growing up, computers were very accessible, and they were very much starting to become kind of the mainstream devices that were kind of the cutting edge devices in every home. And so, programming back then was a lot simpler. You could, pick up a book on BASIC and learn, programming skills, and there were magazines like Compute Magazine that really enabled the amateur person to kind of really learn about technology right out of the gate. And so that's how I kind of got interested in it. And then really it was that whole why question. Why does this work the way it does? How does it operate? What goes on behind the scenes? And that's what really got me, and that's the bug that bit me. And that's how I've stayed true to going on to get an electrical engineering degree and a master's in ECE as well. And now, of course, I'm doing a lot of stuff in software engineering, but it's all the whole question: why does something work the way it does?
Okay.
So, Nick, what is ECE?
Oh, I'm sorry, electrical computer engineering.
Okay. Well, since we just briefly heard from her, how about you, Stacy?
So I was a bit like Kaylee there, where I loved math and science, and that was, I knew I wanted to do something with math and science, really, really love math, but I didn't want to be a high school teacher because I just didn't think I would enjoy that. So I was lucky enough to have parents and some of my teachers that helped me look at what else I could do with something like math and science. And I think that's one of the keys, is that if you don't have somebody that points you in that direction, engineering can be so vague that a lot of people don't get pointed in that direction.
Yeah, definitely. And last but not least, Tom, what's your life story?
Well, unlike my colleagues, I am not an engineer. I do not have an engineering background. I did excel in math when I was in school from elementary on, but I didn't really have any direction as to what I could do. So I was one of those kids, stuck in an honors class saying, okay, tomorrow when I go out and get a job, when am I ever going to use this in real life? Not knowing all the applications. So I spent the first 25 years of my professional career as a commercial lender for various New York-based commercial banks. And about 7 years ago, I took a left turn, and I ended up at ETI. And after about 6 months, 7 months consulting for them, they offered me a position. And at first I said, why do you want me? I have no idea what you're talking about. And over the last 7 years, I've probably purchased over 100 textbooks to teach myself so that I could at least speak intelligently to other engineers or other business professionals in the industry. And I've learned that there are, surprising to me, that there are a lot of gaps that aren't being filled, that aren't being addressed. And I think it all comes back to education and the manner in which we convey these teachings to students and potential professionals.
So do you think that, because you have a little bit of a different background, obviously, than the other three panelists, do you think that there's a specific change in the education system that would have put you on the path to more of an engineering degree a little bit sooner?
Yeah, I think that if someone like our president and CEO had come to our classroom, and I've given this as an example to Glenn and Beth when we talked about doing all this, and I said, if a kid was sitting in a classroom and on a screen there was just a bunch of ones and zeros, and all of a sudden that translated to a scene out of one of the top video games that they like playing. Now all of a sudden you just open up a kid's eyes saying, really, that's what it's all about? I mean, they don't realize behind what Kaylee was saying about the phones. You don't realize what's behind all the things that you enjoy. And for someone like myself, yeah, it would have been nice to have some direction. I'm not saying I would have been an engineer. The only electrical engineering schools that were courting me was either for for sports. So, and I said, okay, what am I going to do when I get there? Other than play sports. So, yeah, it would have been nice. It would have been nice to have some options. It would have been nice to see some things that I would have been able to apply.
Tom, building on that, I, as a high school teacher, would have loved for engineers to come into my classroom and just give me examples of what they do. And so part of what I do now is I give back, and I do that exact same thing. I go into the high schools here, and I have lunch with the kids. There's a couple of high schools with engineering or STEM clubs, which I hadn't even ever heard of. And also just I have a few teacher friends. And so I asked them, hey, can I come and talk to your students? And so I've just gone and done a 20-minute, here's what I do, here's what where I came from, and just allow them to ask me questions about what it's like to be an engineer.
Yeah, and I have a nephew who's a high school teacher in the area, and I'm actually trying to get him involved with Casey and everyone over there to see if they could broadcast what we're doing here today, and to make arrangements for us to come in and sit down with some of their students and do exactly what you're talking about.
So what you guys are discussing is essentially what we have done and formalized through that whole STEAM Ahead program that we're launching here in Manchester. We've started to pilot it actually this fall. The pilot program started at West High School here in Manchester, New Hampshire. We got 70 students that are incoming freshmen, and what we essentially have done is partnered with the public school system from an education delivery perspective, the higher education institutions, community colleges, the University of New Hampshire, Granite State College, a bunch of other college partners, and the business community. And what we've actually done is built a collaborative education environment where the student gets in classroom experience in a different teaching style than the traditional, one teacher to 25 students, that's lecture and homework mode. It's more group exercise mode. And then what they do is after a year or two of actual experience, they start to take college prep classes in some of the engineering, science, technology, math, and arts areas that they're interested in. And they also get internship opportunities while they're in high school to start to collaborate with local area businesses. So not only are you graduating high school with essentially a 1 year of your college degree and path set, but you're also starting to gain some interest and figure out, hey, do I like working in a digital interactive agency, or do I want to work at a different company like Deca Research that builds physical robots and other electrical mechanical devices, and where does my interest lie? And so I think I think we're all talking about the key, which is business involvement in the education delivery and getting involved in the outcome of what the education is supposed to be, and also providing the mentorship opportunities for the students that are actively pursuing or interested in pursuing these types of careers.
I think the other thing, Nick, building on what you just said, and it's great what you're doing, I think the other thing is, and I've had this discussion with Casey a little bit, it's not just the businesses, but we have to get local government to support what we're doing, because we had an opportunity several years ago, and we proposed that instead of building a wireless internet service provider from scratch, that one of the universities that we were working with, we said, why don't you let them have it as a non-for-profit to service the community, let the student body work at the company. Obviously, you'd have to hire some professionals to run it who know what they're doing, but the experience that they're going to gain plus what they're giving back to the community, you would be building a secondary economy, because other students would want to come to that university, be part of that company, and when they walk out, whether you're a business major, a tech major, or an education major, you walk out with some real practical, real life experience that you can now put on your resume, rather than coming out with a degree and saying, okay, I'm whatever, a business major or an engineer, and realizing that that's not real life. It's good that you have a foundation, that's important, but to have that practical experience and then to interact with the community and give back, and you're starting from that level, that'll continue on. So that's also important for us to succeed.
Okay. Just going back to Nick briefly. So obviously we've talked a little bit about the benefits to the student for these programs working with businesses, but what would you say, and I guess you're in sort of a unique position to answer this given both what you do professionally and the groups you work with, what would you say is the benefit to the businesses for, putting the resources into these types of programs?
Yeah, so, just like the rest of the country, here in New Hampshire, we have challenges in terms of actually, getting the tech talent that we need. And so for us, it's kind of a long-term vision and a long-term play. It's I don't think there's any short-term gains that we're looking for necessarily, but it's a long-term 6 to 8 year investment in terms of could we, this is a pilot program in the sense that could we educate and train and essentially grow our own tech talent in our own backyard by basically partnering with, the K through 12 delivery system, partnering with the local colleges and universities, and collaborating with those two partners to say, hey, as a business community, could we essentially see our own graduates coming out of the systems that we're expecting? So it's more of a longer term vision that we have as a business and business involvement, but it is a proven model. I'll tell you that when we bring on interns through colleges and local universities, our success rate with those interns in becoming full-time employees on our team is much greater than trying to recruit someone out of Texas and move them into Boston, into the Boston market, because the weather differences, the culture differences in different parts of the country. So we're looking at this and saying, can we grow our own tech talent in our own backyard and basically fill our future pipeline needs that way?
So Casey, same thing here. So at Caterpillar, the job I had previous to the one I have now is I was an engineering talent manager and setting up a strategy worldwide for how we get engineering talent. So we're really worried about the pipeline and the diversity of the pipeline, and so doing the programs like what Nick's talking about are incredibly key to us, because we know we have to, it's one of our things about giving back to the community, and we're a big company, and so we do think in a lot of the cities that we're in, we're the big player in that city, and it's our responsibility to take a lead and do some of the programs like what Nick's talking about. And it's definitely a long-term issue, because we do know, even right now, that we have issues trying to fill all of the technical needs we have. And really, when you get into some of those more specialized, higher education requirements. But definitely agree with what Nick's saying, both locally, but also the bigger picture about talent we need in the U.S. and even outside of the U.S.
Okay. So let's talk a little bit about the biggest challenges in this. Are they societal? Like, I don't know, kids don't want to be considered like a weird engineering nerd, or are they more education, the infrastructure, how education's set up, or what would you say are the maybe top two biggest challenges, Kaylee?
One of the things I see is that STEM is not easy. It requires focused thinking. And I think in our multi-technology, multitasking-driven world, that's very difficult to sit down and actually work through a problem set, to stare at a problem and not know the answer right away, and not be able to Google it to help you. And so I think it's just encouraging kids to try and to make mistakes and to stay focused, and that's what engineering is all about. I think if we can do that, we can overcome one of the biggest challenges.
I'm going to maybe disagree with Kaylee a little bit. So, so part of it, I think things like medicine and law are also really hard, and we don't have a problem with people going into medicine and law. So when I look at it, I think we talk too much about it being hard. It is hard, and if somebody knows they're going to go into a STEM degree, they know they're going to have a lot of math and science education requirements. But, if I look specifically at engineering, people don't know what engineers do. So I'd be willing to bet that I have a lot of friends that are engineers, and I'd be willing to bet that their families could not explain what they do. And that's somebody who lives with them day in and day out. And so if their families can't describe it, think about some of the teachers or the counselors that don't even know an engineer or know a scientist and are trying to explain to kids what they might do with that degree. And really what they can look at is they can look at the schooling, and they're like, oh, that looks really hard. So I feel like we need to get the word out there on what an engineer or a scientist actually does once they're out of school.
I think that's a really good point, because sometimes I come across things and even I don't know what they are, so I don't know how I would have figured it out 15 years ago. What about you, Nick? What do you think are the biggest challenges?
I think we're touching upon some of them. I think the lack of mentorship, I think, is a big one. I think if you grew up in a household, so I was very fortunate. My mom was a math teacher, my dad was a chemistry professor, and at the end of the day, STEM is really all I knew, right? So I grew up in an environment where I had two built-in mentors. And then they connected me with other people on campus that also became mentors of myself. I took to a mentor in high school that was a physics teacher there that really kind of said, hey, Nick, you really should think about, I was thinking about a medical degree originally, actually pre-dental originally. And he kind of pulled me aside and said, look, I think you really should think about engineering. Here's what engineering is really like, and here's what it's about. And let me connect you with a couple of, electrical and mechanical engineers so you can kind of get some exposure to what they do day to day. So I think the secret in all of this is mentorship and kind of building up kind of an ideal mentor in everyone's eyes in some ways to say, okay, that's what I want to become. What they're doing is really cool. I want to know how an iPhone is built. I want to know how the antenna works in an iPhone, and I want to really do a deep dive into it. And so I think it's following people's passion and basically building up a mentor around that.
Okay. Yeah, I mean, it seems like you guys are coming up with a lot of the same type of answers with the making sure kids know what engineering is so that they can decide whether it's something they want to do or not. And what about you, Tom?
I think that one of the things that we need to impress upon children from day one is that learning is a lifetime journey. That when you finish studies and you get a degree, that's not the end of it. That's just part of it. And I think that sometimes we're so caught up, and I understand because of the business side of it, that we're focused on a percentage of kids getting a certain grade or passing a certain standardized test. The schools get funding to do other things. But it seems that we've moved away from actually learning versus how to take tests, and they're not the same thing. I would rather have a kid work on one thing and learn it very well and understand why it works the way it works versus learning multiple things, just memorizing things. It's okay, I took a test, I got 100, and when you ask them, I mean, we have students who come here right out of college, and we ask them basic questions on things they should know. Ohm's law, things that they should understand in their field. And they can't memorize or can't explain things properly, and they should be able to. And I think part of it, and some of my opinions are really based on discussions with teachers and their interaction with parents about, well, how's this going to affect my kid's GPA and what college they're going to get into. If they don't understand what they're doing, it doesn't matter what college they get into. I would rather have a kid who worked and went to school part-time and didn't go to a great school but put his life into it or her life into what she's learning and knows it in and out versus someone who might have gone to a great school, just did well on tests but doesn't really know how to apply it. And I'm not saying that that's the way the situation is, but I'm just saying that we put the emphasis in the wrong spots, in my opinion. You should learn, and yes, you have to get good grades, and there has to be some kind of measurement to know where you're at, but at the same time, it should not be the only measurement of how smart you are or how well you're progressing. I think that you have to look at what you understand and can you apply what you're learning to your studies.
I have to agree. I'm sorry, I cut you off, Casey. I have to agree. When we interview candidates, that's the number one thing we look for is someone who's dedicated to the field and is a lifelong learner. I teach a couple of classes at a couple of local colleges, and when I go into those classes, the biggest thing I say to them is, look, you guys are going to have 14 weeks with me, and 2 lectures a week. If you really calculate that out, that's a total of what, 40, 50, 50, 60 hours that you'll have FaceTime with me. My goal in those 40, 50, 60 hours is to teach you how to learn, not to teach you necessarily the subject. I mean, you're here to learn a subject for sure, but to be successful in, I think, STEM and for that matter, any field really, you have to dedicate yourself to a commitment to lifelong learning. And I'm glad you brought that up, Tom, because that's one of the key things we always interview for right off the bat.
I just think we take pressure off the students when they're not sitting there constantly thinking about, our president and CEO was also a professor in the UK and here at NJIT, and he shared stories with me about the first day of class saying, well, what will be on the test and what's the required reading, and he's like, well, I'm teaching the class, I'll give you notes, but as far as required reading, you should read as much as you can. And when he says that, he's not joking because he has a library of over 10,000 books just here at our company. So it gives you a different perspective on learning because, as I said earlier, it's really a never-ending. I mean, it's a journey, a lifetime journey. And the more I'm involved in this industry and I see how things change from minute to minute and how you can specialize in one particular area, it just amazes me that when someone comes out, they really don't have a grasp of what the industry can provide to them as far as opportunities and learning. And I think that's where we fall short, and we need to re-emphasize that. And I'm sure Kaylee, as a former teacher, can address that as well.
Actually, that's kind of a good lead into my next question, which is what has engineering, or Tom working in the engineering field, allowed you to experience that you otherwise wouldn't have? Like what, if you were going to talk to someone who was, say going into high school and to explain engineering and like the cool opportunities that it can afford you, what would you tell that person? And Tom, you can start since you are.
Yeah, I tell you the truth. If I had more time, there's a course at Stevens Tech in Hoboken that's perfect for someone like me with a business background. I think what I would tell somebody is that if you have certain skill sets or if you have certain interests and you're willing to apply yourself, and there are so many areas that you can look into. And there are engineers that I've met who maybe aren't as good in their application of the work that they do, but because of their knowledge, they're great business development people. And people don't understand and realize that business development is not the same as sales. I'm not selling you a car, and I'm not knocking car salesmen, but I'm trying to develop a relationship. And what I didn't realize first coming into this, that I've learned over the time that I've been here, is that everything I've done in my prior career, I've applied here. When I sit down and I talk to real estate developers, people that I know, former bank clients, and I say, well, now that you're doing this building, are you considering a smart building? And they're like, well, what do you mean smart building? Distributive antenna systems. Are you looking at certain things in order to make your building more green, utilizing? There's so many things that I've come across that I've now been able to cross back over to where I came from. So for me to talk to anybody going into school, I've always said this, and I said this to my kids. I said, don't go to school the first 2 years out of high school, 3 years. Get a job. Temp. Work for as many different industries as you can until something catches your eye. Not to lose sight. You can still take courses at night here and there just to keep yourself involved, just general basic courses just to give you things that interest you. It's not a race. There's no time frame saying that if you don't have a degree by the time you're 22 or 25, that's it, you're out of here. I would rather they take their time and find their way and love what they do, because I think that's part of the biggest thing. If you wake up every morning and look forward to what you're doing, that's a great thing. And not a lot of people could say that.
That's true. Okay, so Stacy, what about you? What has engineering allowed you to do that you otherwise probably wouldn't have?
So part of it is just an opportunity to connect with so many people around the world. I would have to say that I never had that aspiration that I wanted to work all over the world when I was a little kid. But the thing that's been really great about engineering is that I've met so many people, and I think knowing that we're engineers and we have this certain, obvious interest in technology, it gives us a common language. So I've met people that do really different things, and I've been able to mentor a lot of them, and I look at what all these different people are doing, and I feel like I've been able to make a difference. Because I do think that people, bottom line, want to make a difference. They want to enjoy what they do, like what Tom said, because I think that's incredibly important. But I also think, especially the younger kids right now, they want to feel like they're making a difference in the world. So when I look at it, I've got a lot of friends that work in water, and water might sound like a really boring thing maybe to work in, but if you think about water, the water system that we have in New York City was built around the time of the Revolutionary War, and so that's really old. And so there's a lot of new technology and new engineering things that could be done to upgrade that system and make sure that it's still drinkable water. And those are like really basic things that if you could make sure we have drinkable water, that really makes you feel like you're doing something important.
Yeah, agreed. What about you, Kaylee?
I think I just really enjoy engineering. It allows me to be creative, allows me to keep learning, as all of us probably are. We're all lifelong learners, as Tom was saying. And specifically, I really have gotten a kick out of going back as an engineer. Now I am able to go back into the high schools and do those hands-on projects that maybe I didn't do when I was growing up. And so I absolutely love getting my hands dirty with these kids and working on these circuits and trying to make them work. And to me, that makes my job enjoyable, and it gives me energy to come back and continue my work as an engineer.
Definitely. And Nick?
Well, I started a business that builds things for our customers. At the end of the day, that's what engineering is all about. And I think that if I hadn't, gone to school for or had the passion for engineering in general, I wouldn't be doing what I'm doing today, which is essentially building things for all of our clients and showing them that, building things with hardware and software can lead to gains in the business. So yeah, I think engineering is all about building things, and that's what I do all day, every day.
So my next question I'm pretty excited about. I tend to write a lot about how toys can influence kids and the skills they're developing and how important they are. I usually have the angle of how they affect girls in particular, but I just want to know what toys you guys think are really great or are terrible, and kind of why. Stacy, do you want to start?
So the basic great ones, I think, just to go to that creativity and building things, are things like Legos and, I think most engineers have had some fascination with Legos, it seems like. So Legos have got to be in there as far as a good toy. But then from I am kind of the same way with Casey as far as looking at which ones encourage girls, because there aren't as many toys for girls. If they always talk about the pink aisle and everything, the pink aisle is about princesses and stuff like that. And so a couple years ago there was a campaign to talk about it was the 50th anniversary of Barbie, and so there's this big campaign about what should Barbie, the 50th anniversary of Barbie be. And so a lot of people from the Society of Women Engineers went in and voted, and we were really happy because we got computer engineering Barbie, which is like a big win. So I was waiting, she was back ordered and all this type of stuff because I wanted my own computer engineering Barbie. So I thought, ooh, this is a great win for little girls to see Barbie as an engineer. Well, so then somebody wrote a book that accompanied computer engineering Barbie, and they talked about how Barbie went to work and, she had this great idea for a game, but she needed, I think it was Stephen and John to help her code or something like that. And I just thought, here we had this great win with Barbie that was an engineer, and then the book that accompanied it made it just sound like as if she couldn't handle the job, which is so not true. So I like the Barbie concept, but then let's move her into this great empowered super engineer type thing. So it kind of was a fail on that end.
Yeah, we had talked about this before, but I thought that was such a it was such a win, and then it was such a not win. But the one thing that did encourage me was how many people were like, this is ridiculous. Barbie or any girl is totally capable of writing the program herself. So I thought that was really interesting.
What about you?
And then, just one other thing, sorry, about the good things is Goldilocks, which is a relatively new company that started by a woman that studied engineering at Stanford, and she's just really trying to break the stereotype to say that girls like to build things, but girls like to build things with a story. So there's a story attached to all the Goldilocks stuff, which is a unique kind of psychology of how girls like to learn. But
yeah, if you look at the articles I've written, it's very clear that I'm a big fan of Goldilocks. I totally agree. I think they're both, well, the computer thing was a little bit of a fail, but the Goldilocks, I think, is a really cool sort of idea. What about you, Kaylee?
All of those are great. I also like the traditional, the marble roll down, so anything that you can build. And actually, the Brio train tracks were my favorite growing up. So just putting together tracks and building. A few other things that I experienced growing up that I think are great ideas. I had a rock tumbler. I was really into rocks. And so if you're trying to, I studied the chemistry and the chemicals that would go into it, and that was just a kit that I had. And so that could be something, because then the rocks were turned into jewelry, which honestly I didn't actually care about, but I just loved the chemistry of it. But if you're trying to get girls into it, that could be one thing. Also, remote control cars or airplanes, and it's not the story of or the life of a remote control car at our house was, okay, you build it up 30 minutes, you play with it 10 minutes because you drive it and it crashes, and then you spend the next 3 hours trying to fix it. And so it's having those toys that you can just destroy and then try to put back together. And so I think it's toys like that that kids can really own and not be afraid to mess up and make mistakes and crash it in hopes to try to rebuild it.
Okay. What about you, Nick?
Well, so I have 2 young daughters, and being kind of STEM-oriented myself, I'm really passionate about how am I going to kind of get them interested in STEM, or at least show them what STEM is really all about. And so a couple of things I've been doing lately is we've been building some model rocket kits, and we've been launching model rockets, so to kind of pick up on that whole build something, launch it, enjoy it for 30 seconds and then have to rebuild it again and kind of figure out how to launch it up again. I think that's really cool, and I think they really love it, and it's a lot of excitement really quickly. The other thing is this summer I found a kit out of the UK on Kickstarter that was really kind of interesting. Both of my girls really love to draw, right? So they love to paint, draw, so they're very artistic in nature. So I kind of thought about this, and I said, well, what could be a way that I could build kind of some sort of STEM education around the whole artistic side of what they enjoy. And so there was this robot kit that basically lets you put crayons and markers in it, and then you program the robot through a computer over Wi-Fi, and it basically will draw what you've basically drawn on the screen, and it'll kind of act those out, and you program it to say, okay, draw a circle with this type of radius, and then move in this direction, and all in the meantime, it's kind of like an Etch-a-Sketch on the ground. And so I'm hoping that when they get that for Christmas, that might spark a little bit of interest in them as well. So it's all about taking the interest that they already have and trying to see if there's something that could just stretch that a little bit to start to bring some STEM knowledge into the place.
Yeah, I mean, I think you make a really good point, because I think with the Goldie blocks, like at least for me, I was a really big reader. So I think having something like that where you could read along with it while you're sort of learning the basic whatever concept, math, engineering, is like a really great approach, particularly for, more of a non-traditional demographic. Girls haven't typically been targeted with these type of toys, so I think it's definitely like a really great path that we're on. What do you think, Tom? What do you think are the best toys on the market?
Well, I'm a fan of Goldie blocks. We've talked about it, and I think something like that is really very cool from a young person who struggled as an engineer student. Finding her way as a female in a predominantly male industry, and I think that she took her experience and turned it into something very positive, and I'm a big fan of that. But there's so many things out there, both electronically and things that I'm just learning. I'm looking at. I have 3 grandkids, and I'm trying to figure out where to steer them in the right direction, trying to keep them both balanced in mind and body. So there's a lot of fun things out there. It's just a question of trying to balance it, and I think that for parents going forward who want to do this for their kids, very much like what Nick is talking about for his daughters, you have to be involved, and you have to set your schedule around some type of interaction, so that this way they get a broad sense of the things they can do. And the toys are cool, but they really need to understand things beyond that, and I think everything that everyone said so far is spot on.
Toys, yeah, are great at home, but one thing that even comes to mind for me is just cooking. I remember I got a cookbook, and there's so much science about the thermodynamics and the cooking and the proportions. And so when you're thinking about kids and let's double the recipe, okay, what's 2 half cups? I mean, that's a huge concept for younger kids. And I know my mom always let us make huge experiments in the kitchen, so we thought we were smarter than the cookbook. Well, the cookbook says bake it for 20 minutes at 350. Let's bake it for 15 at 400. And then, that didn't work. Let's try it again. And so just just that whole process to me is just engineering right there, but we didn't even know. We were just having fun in the kitchen.
Yeah.
I think that's a really good point.
Okay, so Stacy, you've obviously done a lot of work with the Society of Women Engineers and Women in Engineering. So how would you say that we need to tackle the issue of the discrepancy in the ratio between men and women in engineering?
So some of it is the media part of it, and we always talk about how we need a cool show for engineers and one that highlights smart women. So we do have something like The Big Bang Theory now, which I love from a comedy perspective, but if you look at it, it's like the really fun, cute person is the waitress and not the engineer. And so it'd be nice if we could get to the point where it's just normal. I have this quote that they've used a lot within the Society of Women Engineers, where I want it to be normal for people to see smart, beautiful, intelligent women as engineers, because whenever I meet somebody on a plane or something, they're like, oh, you're a woman engineer. There's not that many of them. And I think if we could get it out there and just have regular characters be engineers in these in the media and in TV, it would start making it so that it's not such a unique thing. We want it to be not unique to see a bunch of women engineers. We want it just to be like, yeah, they can be an engineer. It's normal. So have those people out there for them to see.
Yeah, I mean, I think people just don't think of, when you think of an engineer, like you picture. Actually, there's an interesting sort of experiment where, people ask you to picture an engineer, and a lot of people end up picturing like basically a white male, which is the majority of engineers, so it sort of makes sense. But I think it's a challenge to change that.
Right. I'd seen some astronauts talk at a tribute to Sally Ride last year, and it was funny because the one woman got up there and she had other friends that were astronauts, so there were like these 3 women that were astronauts, which means they're pretty impressive women, and that their little boy was around them a lot, and so he asked his mom, he said, well, can guys be astronauts too? And I thought that was so, you never hear that, and so I just thought it was kind of funny, because it's like, not that we want little boys not to think they can't be engineers, but just the fact that this little kid had that experience was kind of special.
Yeah, it's something you don't hear very much. Okay, well, that's basically all the time we have for this Engineering Live. So I'd like to thank everyone for watching today, and also our panel, Nick Sogu, CEO and President of Silvertech, Stacy Del Vecchio, ECN Editorial Advisory Board Member, former President of the Society of Women Engineers, and Additive Manufacturing Product Manager for Caterpillar, Tom Economou, Chief Operations Officer for Electromagnetic Technologies Industry Incorporated, and Kaylee Farnham, Product Marketing Engineer at Keysight Technologies. For the E17, I'm Casey Panetta, and thanks for tuning in.